Hello, everybody. This is Joe Buck, Applications Engineer for Selway Machine Tool. This is our Ask Apps video series. So in today's episode, what we're going to go over is a common question I get from a lot of our customers. How do I get my probing integrated into my program? So the answer is it's pretty simple to do the basics. So let's go ahead and let's get started. The example I'm going to give you today is really, say, for instance, maybe I have an op1 and I'm milling all the way around the profile of the part, the periphery of the part. And let's say I don't have any sort of work stop or great relocating method. Well, what I can do is I can go ahead and put a probing routine in the beginning of the program. And what that'll allow me to do is allow me to load and unload the part. And if there's any error in position from part to part, the probe will go ahead and pick that up. It'll reset the work offset, and that way I'm always milling in the middle of my workpiece. We're going to go ahead and we're going to set our work offset in the middle of that 4" by 4" block, and we'll go ahead and get started. I'm going to park my cursor somewhere right there. Now, all of my probing routines exist in two places, in my offsets display or my edit mode. So I'll go ahead and I'm going to give this example in the edit mode. So one of the things I'll point out is to get to my VPS where the probing functions live and the templates live, what I'll do is I'll hit the edit button once, and you'll see what that does is it jumps the cursor up to the very top row of tabs. So now I'm going to go to VPS. And as you can see, I already have the template pulled up. So let's go all the way to the highest level of options here. So once I'm in VPS, I get this first menu. We'll open our probing menu. So I'll hit the right cursor key here, and that'll bring up our probing menu. So I'm going to cursor down to work offsets, since that's what we're setting is our work offsets. And I'll open up that directory once again by hitting the right cursor key, because I have this right caret icon right there. So for this example, as I mentioned before, it's a 4" by 4" block of material, and I want to be able to make sure that I'm always setting my work offset to the center of the block. So for that, I'm going to choose a rectangle block routine. Once I have that highlighted, I'm going to hit the enter button here. Now that brings up the template, and all we have to do in all of these VPS templates is just start by working from top to bottom and fill in all the blanks and fill out all the information that's relative to the action that we're about to perform. Now, the very first thing it's going to ask me is my work offset. In this case, I will be using work offset 54, but if I wanted to change that, I could enter any work offset value that I want to use, for instance, 56, or even 154.01 would be 154 P1, or 154 P.05 would be 154 P5, so on and so forth. But for this example, we'll go ahead and we'll use we'll use work offset 54, since that is the work offset in my actual cutting program, which we can see over here. Moving on, in my X, I'm going to enter the width of my block. Now, remember, this is my stock, right? So this isn't my finished block. My finished block will finish at 4 by 4. So I might want to include any stock that's on the actual piece that we're probing, not the actual finished workpiece. So in this case, I might want to call it 4.5 by 4.5" piece of stock. Now, here's what we're going to focus on for just a minute here is the Z value. The Z value it's asking me for is an incremental depth from the current position that the probe is parked in. So we haven't gotten there yet, so I have to think a little bit ahead here on this one. And I have to kind of ask myself later on when I want to park the probe above my workpiece before I start probing for the rectangle block, where do I actually want to park that probe? I'm going to park it at Z 1 inch above the part, or Z positive 1. So if I'm already at Z positive 1, then I might want to go down another 1/2 inch so that the side of the ball, the ruby ball on the probe tip, will touch the side wall of the part. So in this case, I'm going to stick with this value that's already been populated, this minus 1.5 value, and we're going to go ahead and use that. Now, the next thing I want to point out is this tree of options here. Now, if we're already familiar with the whips, then what we'd probably do is we'd probably pre-position our probe manually with handle jog so that our probe is above our workpiece and looks something like this picture here. But again, we're automating this, so this hasn't happened yet. So if we're already familiar with running it in cycles just by hitting cycle start after we pre-position, let's go over a couple more of these options right here. Well, the one I want to focus on for today is generate code. So that's F4. So if I hit F4, I get this little window that pops up, and it's asking me, okay, I'm going to generate some G code to execute this probing routine. Where do I want to put that G code? Do I want to insert to clipboard, output to MDI, or create a new program? Well, in this case, I've already got a program that I'm using, so I'm going to select option 1. Now, just like that, option 1, put my program into the clipboard here, as you can see. And now all it's asking me to do is position my cursor. I'm using the jog wheel here, and I'm just going to position my cursor where I'd like for that code to be entered into. And once I've established that spot, if you look down here at the bottom of the screen, it says F4 to paste from clipboard. So all I'll do is I'll hit the F4 key. And just like that, you can see I've inserted the probing routine that we just filled out in the VPS template. Now, to get rid of that bluish purplish background color there, I'm just going to hit the cancel key here. And now my cursor is free to float around as it normally would. Unfortunately, this isn't the only thing I have to do in order to make this work. As I mentioned a few minutes ago, we're going to have to pre-position the probe. So for that, we're going to have to give it some G code. So to start off with, I always want to have a safety line. So there's just a standard safety line. We're going to be in rapid, XY plane. We're going to operate in inch mode. We're going to cancel any previous cutter comp, cancel any previous tool length offsets that have been used, cancel any can cycles, and we want to make sure that we are in absolute positioning for the machine's global setting. So once we've done that, I'll give myself a few more spaces here with my end of blocks. And now I'm going to manually key in the starting point for pre-positioning the probe. So the first thing I'm going to do, I like to give myself a point to reference from, and I'm going to drop just a random line number, N31. Remember, folks, that doesn't do anything. It's basically just there for your reference to find a spot somewhere in the program that you can remember. Now, why did I choose N31? Because in this particular case, if I go to my offsets page, you can see that tool 31 is set as my probe. So N31 is the starting point in which I'll know to look for whenever I want to quickly find where my probing routines start. The very next thing I'll do is a tool 31 M6. We'll load the tool into the spindle. Now, I personally like to put an M1 command right after my tool changes. That's just if I'm setting up the job for the first time. If the wrong tool comes to the spindle, I'm not trying to reach for the feed hold or the reset or the e-stop frantically. It gives me some time to stop and think about what I'm doing, so long as the optional stop is actually on. So we'll leave that M1 there. And then the next thing I'm going to do is I like to pre-stage the next tool that's going to run. So for instance, in this case, it'll be tool 1. Remember, without the M6 there, it's not going to actually change to tool 1. It's just going to take your side mount tool changer and position the side mount tool changer so that tool 1 is ready to go as soon as it's ready to execute that tool change. So after I have my T1 in there, the next thing I'm going to do is I'm going to go ahead and position my probe. So let's say G0, G90, G54, X0, Y0, and the block. You'll note that I didn't have to turn the spindle on or anything like that. We're just moving the probe above the center of the workpiece. Remember, this is a rough guesstimate of where the part should be. We're using the probe to update the work offset in between each loadout of the part. So after I have that, let's drop my G43, H31, Z 4 inches. Now, all I'm doing here is I'm enabling the tool length offset for tool 31, which is our probe, and I'm going to stop it 4 inches above the workpiece. I like to give something somewhat comfortable. Remember, this is a rapid position point, and it's not protected, folks. We have not turned the probe on yet, so we want to stop somewhere nice and high above the part, somewhere nice and safe, and somewhere we're not flipping out or freaking out to hit the feed hold or the reset or the e-stop in case we see something that we don't really like. So now the very first G code that we're going to get familiar with here that we have to memorize and input is our turn on probe code. So I'll put a note in here, turn on probe. And if you're not 100% familiar, remember anything that's in parentheses is non-executable, it's read-only. It's really just, again, for operator reference. So turn on probe. And the G code for that is G65 P9832. Now, in order for G65 P9832 to work effectively, in other words, in order for the probe to actually turn on without any alarms, I absolutely have to have a tool length offset enabled for that active probe tool number, in this case 31. So what does that mean in plain English? I always have to have my G43 H31 code, or H whatever your tool number is, above the G65 P9832 line. Now that we turn the probe on, the next G code that you guys may or may not be familiar with is what we call a protected positioning move. This means that the probe is on, and if the stylus runs into anything that shouldn't be there, for instance, a clamp, or maybe the workpiece isn't in the right Z location, in this case, this will stop everything dead in its tracks and will prevent the machine from just taking off and running. So in order for us to do that, and I'll put a note first, we'll call this protected position. Okay, and that G code was now going to be G65 P9810. Let's bring our Z a little closer to the workpiece. Z 1 inch with a feed rate of 150 inches per minute. So for those out there who are like, whoa, 150 is kind of fast, right? Actually, when we're in 9810, as long as we're under 200 inches per minute and the stylus hits something that shouldn't be there, it will actually stop the machine fast enough to where the stylus will not break. So anything that 200 or below is perfectly fine for a 9810 move. Now we have that position 1 inch above the part. So if I actually parked my probe at 1 inch above my workpiece, and I asked in the routine, which is this H value, which we filled out in the template, the DPS template, to go from its current position down 1.5 inches, then what that basically means is that the ball of the probe tip will be 1/2 inch below the surface of our workpiece, and that's where we're going to probe to find our X and our Y center of our part. So all I have to do now is just get rid of that spacing there. We'll keep all these parentheses and these comments in here for our reference. And basically when this is done, it's supposed to turn the probe off when we're using our 9995 routines. However, I like to have a little bit of safety and redundant code is okay by me, but we want to make sure that the probe is turned off before we put it away. So I'm going to put a G65 P9833 end of block, and then I'm going to command this to all go home. Because remember, when it's done, it's going to stop at that 1 inch above our part. It's going to park there when the rectangle block routine is complete. So let's send everything home with a G0, G90, G53, Z0. And then I'll put one more optional stop in. And then let's get rid of some of this spacing here just to kind of clean up our G code a little bit here. And as you can see, that is all of the code that we need to add it in order to make this rectangle block work. If you notice up here, you'll see in this red note that everything we just added has not been saved yet. So be careful here. Make sure if we look here, it says memory button will save and load. So make sure right now, before we do anything else, hit the memory button. And now, as you can see in our actual program, all that information that we just put in is now stored, ready to go. I'll hit reset to bring my cursor back to the top. I'll make sure I'm in memory mode, and I'll go to my graphics key here, and we'll hit cycle start, and we'll look for any errors. There are no errors. It's kind of hard to see what we actually did here, but if I put it on single block and I cycle through by hitting my cycle start button here, step this through line by line, you can see the first thing it did was take it from the current machine position, bring it over to our work offset, and from here, I will have to turn the single block back off and let it run its routine. So we would love to hear from you and answer any of the questions you have, such as any features of the machine, any G codes that you're not super familiar with, anything we do to help you guys out, we're here to help. So once again, drop it below and we'll make sure we'll make a video to answer your questions. Thanks again for tuning into this episode of Ask Apps. Again, my name is Joe Buck with Selway Machine Tool. Looking forward to hearing from you guys soon. Thank you.